Hi all. Thanks for joining us this afternoon. My name is Tim Fu. I'm from the MIT Energy Club. Just a quick introduction. You're attending one of the lectures in the lecture series Blueprint for Energy Efficiency. It's a webinar speaker series hosted by the Center for Business and the Environment at Yale and co-sponsored by the MIT Energy Club. My name is Tim Fu. I'll be your host for this afternoon's presentation, which is titled Enabling the Smart Grid Through Smart Software. We would like to acknowledge the Emily Hall Tremaine Foundation for their funding support for the Carbon Finance Speaker Series at Yale and MIT. A word about the speaker series very quickly. The Yale Center for Business and the Environment and the MIT Energy Club are pleased to present the 4th annual installment of the Carbon Finance Speaker Series titled Blueprint for Energy Efficiency. This series of public webinars will feature the latest developments in energy efficiency, policy, investment, technology, and community engagement with a specific focus on the DOE's Better Buildings program. Today we're joined by Andy Frank, who is the VP for Business Development and Efficiency 2.0. Andy basically articulates and executes Efficiency 2.0's business strategy. He's worked with the New York City Economic Development Corporation and Green Order, where he had a huge role in making GE's real estate portfolio more efficient. Andy has a bachelor's degree from Harvard University in Environmental Science and Public Policy. He's a lead AP and is an extremely qualified individual to talk about the role of software and data in energy efficiency today. Please welcome Andy Frank. Andy, you're welcome to take over.
Thanks, Tim. So as Tim said, I'm going to be talking a little bit about how smart software can be used in the context of energy efficiency and the smart grid in order to really move the needle on many of our nation's energy priorities. So I'm going to be taking you through a short deck that sort of outlines our approach, talks a little bit about the work that we've done in terms of smart software, and then shows an example of its application in a few programs that we're currently running right now. Then we'll open everything up to questions. So just before I get started, a quick little background on Efficiency 2.0. We're based in New York City, downtown Manhattan. We've been around in one form or another for about 5 years now. A large part of that time has been used building our energy and use algorithms, which form the basis of our smart software, so to speak. And we essentially run programs for utilities, governments, and other folks that are looking to meet their energy efficiency goals, both in terms of verified energy savings to meet energy efficiency portfolio standard goals and other energy goals, including enrollments in other energy-related programs. So I'm going to walk you through how we think about things and some applications of smart software in the smart grid space. So we basically break down what we think is important to moving the needle on energy efficiency into 4 buckets. For all of these, we feel strongly, and we've built our software and our programs around this, that personalized information is paramount. If you think about most other parts of your lives, you sort of expect to get personalized information and recommendations. So if you're talking about finance, Mint.com or other financial tools will tell you exactly how much you're spending, what you can do to cut down your spending, or other ways you can save. If you're thinking about the consumer space, anything that deals with the social media, Facebook or Foursquare, or in the realm of purchasing, an Amazon or a Netflix, you're getting very personalized information and allowing you to lead to that next step. So there's no reason why we can't do this for energy, and that's essentially what we've attempted to build over the years. So basically, as I said, we break our philosophy, and all of these our components are built into our software and product, as I'll show you, into 4 buckets. So the first, as I mentioned before, is personalized energy savings information. So sort of going beyond tips to very, very specific and very, very actionable recommendations that are customized to each individual household. And I'll talk about how we do that in a sec. The second thing is goal setting and feedback. It's very important to encourage consumers to set a reasonable but ambitious goal around energy savings, and then to tell them how they're doing compared to their actual usage. You know, if you don't, it's like weight loss. If you don't get on the scale, you're not going to know how much you actually lost. The third is social context, so giving people better information about how they compare to others in a variety of different ways. And then fourth, and this is something we're very excited about, is actual financial incentives for saving energy. In our case, a rewards program for folks that end up saving energy in their bill, and that's done through a partnership we have with another New York City-based clean tech firm, Recycle Bank, which is a leader in the green reward space. And so we feel by combining these principles into our smart software, and I'll show you what that means in a little bit, that we're leveraging the best practices, not only in terms of general consumer marketing, but also in terms of the literature around behavioral science, which we can get into later if folks desire. And the goal here is simply to generate the most energy savings at the lowest possible cost. You know, there are, as this series I'm sure has talked about or will talk about, there are a variety of policy drivers out there, both state and federal and local level, that are pushing for greater cost effectiveness and greater scale in energy efficiency programs, and to the extent that entrepreneurs and companies in the space can leverage the best practices from this industry and other industries, the more likely we are as a country to meet the ambitious goals that we've set forth in the energy and carbon arena. So those are sort of the tenets of what we've built into our software, and I'll talk to you a little bit about how we're able to do that now. So first off, we put all of this into an actual program. We call it the PEER program, the Personal Energy Efficiency Rewards Program. And like I said before, it's designed to generate verified energy savings to meet state and utility goals. Just very simply, it's a multi-channel marketing approach. So we feel very strongly that you need to reach people in a lot of different ways and at different times. The key in moving the needle on behavior is reaching someone at the right time, at the right place, and with the right message. And so we strive to do that any way that we can. And then we track the savings using various bill analysis strategies, experimental and quasi-experimental design, which I'll get into a little bit here, but happy to also answer questions later if folks have specific questions on the evaluation methods. So a little bit about the software. Like I said, we've been building this for quite a while. Essentially, what we've built is what we call a hybrid statistical engineering model. And what that means is, unlike traditional energy audit models, which usually take a strictly engineering approach, so you're basically trying to build a home from the ground up in order to estimate home characteristics and savings opportunities. We take, first and foremost, a statistical approach, which means we take all the information that we know about a household at any given time, and because of this, we can be very flexible as to the amount and types of information that we take in. And we use that to basically run a massive multivariate regression based on a large set of databases, information databases that we have in order to calculate what the most likely energy profile is for any individual household, and then therefore what their savings opportunities look like, how to rank those savings opportunities, and what the estimated benefits are. We are, at least as of right now, last I checked, the only ResNet certified online survey tool on the market. ResNet is a standards organization, mostly traditionally in the in-home audit space. So what we've done with our software is made sure that it is as comprehensive as possible in order to basically put almost anything you could put into an in-home audit, you can put into our software in one way, shape, or form, although the purpose of it is very different than an in-home audit. We've then also done, in addition to the base model, we've then also modeled how much sort of savings algorithms for hundreds of different actions and energy efficiency actions and purchases, so that we can actually calculate based on any individual home's profile what their estimated savings are going to be in a number of metrics: electricity, natural gas, carbon, water, their upfront cost, their savings, payback period, etc. So we like to say that our Personal Energy Advisor software knows more about how people in small businesses use energy in the U.S. than anybody else, and we can make this claim because we spent a long time gathering the right data and putting that data together in the right way. So again, the way that we've done this is by essentially taking pretty much any data source that touches directly or indirectly energy use in some way, and running analysis to see where there are significant correlations and integrating that into a model to be able to best guess household energy use characteristics. So, for example, income is something that most folks wouldn't associate with energy characteristics, right? You could, what your home looks like and how you use energy isn't directly dependent on how much income you have. However, there is a very strong correlation between income, appliance use, heating, cooling usage, and so actually knowing or being able to infer someone's income, for example, from property records, tells you a lot about being able to model not only engineering characteristics of a home, but even more importantly, behavioral characteristics, which is something that has been very tricky in the industry for a long time. It's not an easy thing, but it's fairly straightforward to run a building energy model. It's a lot more difficult to try to model folks' behavior inside the home, which in most cases is actually even more important than the engineering characteristics of the home. So we're able to use this and say, for example, we know that you live in a single-family home that's 1,500 square feet in this zip code in the country, and have an estimated income of X. We're able to then take that and provide some very smart disaggregations and able to rank your savings opportunities appropriately. So we're taking into account not only sort of traditional factors that one would put into an energy profile, but also some more advanced things as well. The strengths of this approach are number one, high resolution smart defaults. So we